Okay. For those who are able to turn on their cameras, please turn on your cameras so that it will be a face-to-face. It will be a face-to-face class. Today, I am going to continue on superior interface characteristics, which is a relatively important topic, and continue on principles of fundamental elements observed in common user interfaces. So it will be superior interface characteristics part 2. Thinking about color, we have spent a lot of time in vision and cognition in the previous lectures. The first condition is superior interfaces consider colorblind population. So 9% of the men and 1% of the women are colorblind. So when we are developing an interface, keep in mind that the person who is viewing the interface could be colorblind. Anytime we use color to give information in the interface, we should also use the clear secondary cues to convey the information to those who won't be experiencing any color coding. So in addition to color, you need to provide secondary cues, such as a red stop button, but you say stop here. So the word and color, word is number 1, color is number 2, makes 2 different cues. So if you are colorblind, you read it. And if you are not colorblind, you read it as well. So multiple cues strengthen each other, such as a traffic light and something at the bottom, like OK, error, so, or caution. So support it with the wording or other symbols so that color perception should not be an issue. It could be also grayscale differentiation. If grayscale differentiation is provided, then it's fine. Or having a different text or graphic element along with the color is also fine. When you constrain a person, when you constrain too much, they don't like it. They feel like they are being guided too much. So we need to provide them some landmarks, explorability, paths. They can discover by themselves, yet they are provided with the cues at the same time. So safety, smoothness, and consistency of the natural landscape, being able to come back to the original location all the time gives confidence, and having the confidence increases the success of the user interface. If we are worrying about destroying something, making a mistake, then we don't use the interface. We don't explore as much because we are afraid of breaking something, then we limit ourselves in the interface. Therefore, providing well-marked roads and landmarks, for example, breadcrumbs in the web interfaces are one example of this, provides it. Also, we shouldn't trap users into single path through service. Give the illusion, even if they are the same, give the illusion of having multiple paths, but they are going through this way. In our building, coming from the campus entry point, there are multiple paths that reaches to our building, and you usually follow the shortest path. But still, there are other paths, and knowing that there are other paths, you will be more comfortable and you feel yourself in power. If there was only one path and you are following that path, you won't feel the same power because that is the only path you can go. So, providing multiple ways of doing something, but still people doing the most easiest one, is very good because they feel that they are choosing it. When they feel that they are choosing it, they like it. So, when single use or novice, inexperienced users are concerned, this becomes more important. You need to give some guidance. In order to give some guidance, the first thing is like this home button, or this screen is home. Think about hotel experience. Hotel experience in an unfamiliar neighborhood. You go to a hotel and you try to explore neighborhood, and the first thing you want to achieve is you need to be comfortable with the position of the hotel, and when you are at the hotel, you feel safe. So if you can come back to a hotel from short distances, then you like it. You want to explore further as you learn. So having a home location in an unfriendly environment is pleasing and good. In the interface, when people go back to home, main screen, whatever you call it, they feel like home. That's why people call it home in the web homepage. And they start from there with more confidence. So sense of home is important part of the guidance. Also, when you go into some track, some way of doing a task, it should be easy to stop, easy to exit, easy to cancel. Because once you start doing something and the interface doesn't let you exit, you feel frightened and or bored, depending on what you are doing. You feel trapped. So try to give way to exit, cancel all the time without penalty, so that they don't feel trapped. They feel that they can always stop, and that means a clear path out from the current scenario, current task. And it has a different consequence. In the early days, exiting from application was difficult. Are you sure to exit? Yes, no. So do you want to exit? Yes, no. So you want to make it difficult to exit or cancel. With the command line interfaces, interruption was only possible with Control C. So it was difficult to exit from the current process. But now, with the web, if used between multiple sites, sometimes you exit from the website without even knowing. Suddenly you are in a different place. So easy to stay, easy to leave is critical. Some web applications give you notifications about whether you are leaving the site. They pop up a message indicating that you are leaving the site. So be informed, and then they let you go forward. It is okay because sometimes the structure of the application or marketing idea of the application wants to keep you in. So in those cases, you want to keep people in the application if you have adequate resources in the application. If you don't have adequate resources in the application, you tend to mimic external resources as if your resources. Then you don't want to say that you are leaving the site because that is what you want. You want people to leave the site and still come back next day as a portal or as a starting point. Like banking applications with the standard web browser, turning off the menu bar and all other irrelevant options in the top in the web applications and providing landmarks through the application itself is important. Banking applications does that. When you log into banking applications, they pop up a new window without navigation buttons and going back, for example. Going back, it should not be implemented with the browser back button. Browser back button is something very different than navigational back button. Preserving the session information and the cookies, etc. Session information preservation is important. So browser button should not be relied upon for navigation. You need to provide your own navigation all the time. We have seen what Fitstove was. Fitstove says you have a small target and you have a big target. Okay. From here, going to small target and going to big target has different performance values. Going to big target for clicking and close target This is D. This is another D. Going big targets is easier and faster. Going distant target is difficult, and it affects success. You slow down for small targets, and you slow down for distant targets. Therefore, for important functions, use large objects. Big buttons are faster. Use pinning actions of the sides, bottom, top, and corners of the display. So, in my desktop environment, for example, rightmost corner, top right, top left, these corners have specific meanings, and in order to activate those meanings, I simply throw my finger to the edge without actually targeting this specific point. I am targeting this area. And since this area has a boundary, connected to the edge of the screen, that means the actual area is much bigger behind the screen. So I can aim a hypothetically big box, big button, which actually doesn't exist, but my finger movement or arm movement thinks that it's a big button and at the end of the screen. For example, if I have a button here and I'm coming from here to the button, pressing this button has some difficulty, certain level of difficulty. But if I place this button up here to the edge of the screen, then it becomes easy, because what I do is I only target the edge of the screen, thinking that there could be additional dead space on the other side. So I don't care about the other side. I just target the width. Therefore, I can do it much faster without difficulty. So even 1 pixel boundary can result in 20%, 30% slowdown for tools closest to the edge of the screen, such as you have a button here and 1 pixel is left on the right side. So you go there, click, doesn't work. Click, doesn't work. Why? Because you are on the other side of the button. So connect those buttons to the edge of the screen, or use active regions that are a little bit bigger than the button. So even if you click between the edge and the button, it will still be captured as correct click because there is nothing on the other side. That improves the performance very significantly. That is direct consequence of Fitts law. So pinning actions to the side of interfaces, this is extremely interesting for tablet displays and tablet computers. Edges have specific functions. Those edges are used without difficulty compared to using buttons, because in order to click buttons, you need to be careful. Also, when you have a button like a window, a close mark here, and assume that this is advertisement popping up on the phone, and you want to close it. For a successful interface, this active click area must be big enough for your finger. Even if you don't specifically hit this cross, the region must accept the click as a correct click, because there is nothing else in the proximity. So make active acceptable regions for clicking a little bit bigger than the actual object in some cases, in cases like this, if there are no other possibilities for buttons, additional buttons around, because your finger may miss it, and then what you do is you press multiple times and you spend time and mental effort. This is important. Latency is a bad experience in general in user interfaces. So how do we reduce latency? Today, we are using multiple frameworks, multiple languages, libraries, so they all come on top of each other. Frameworks, user interface management toolkits. Therefore, it slows down the interaction. Given the program logic, for example, if it is a artificial intelligence application, image processing application, database application, sorting certain numbers, sorting the real records, so business application. In those cases, one common mistake is not separating user interface thread from the business thread. When multi-layer approach is not followed, like business layer, backend, forend, front end and back end. If it's a single application, we need to simulate multiple layer of operation with multiple threads. When we use multiple threads, one thread will be responsible from the user interface, the other thread will be responsible from the backend. Just like it's a service-oriented computing. The backend service is different from the front-end service, so they pass messages to each other. In the multi-threaded case, threads communicate and share data. So use multi-threading approach to push latency into the background process, which is the business part. There are some numbers which we will talk, latency experience. These are from the literature. All clicks must be responded first, acknowledged by visual or audible feedback. Either you provide click or some visual movement when you press within 50 milliseconds. If it is more than 50 milliseconds, it will be regarded as slow. Arayüz kasıyor derler ya. Interface is sluggish. So if you go over 50 milliseconds, you start to think like interface is doing something else at the background than what you are saying. So some slowness is felt by the user. If the action is, but that is not the action, that is only the acknowledgement. You can acknowledge and still wait, no problem, but you need to acknowledge. That's important. That was very important problem in Microsoft Windows. You click on file, nothing happens. You believe that the click didn't go. You click again, nothing happens. Click again, nothing happens. After 5 or 6 seconds, 3 copies of the Microsoft Word pops up. 3 different copies. It is still happening in some distributions of operating systems. On my desk in the school, I have a Raspberry Pi. In the Raspberry Pi, there's a Debian-based own operating system, Raspbian, and there is a browser. I click on browser, nothing happens. Nothing happens. Click, nothing happens. No feedback. Click again, then 2 browsers open. So that is because I didn't have acknowledgement for the click, and I thought the click didn't work. So I need to first understand that click worked. Then if I understand that the click has worked, I will wait. I will wait. If I wait too long, then I will think that the machine is slow, but still I will wait. Therefore, acknowledgement of the clicks is important. Clicks or touches is important. If the task is between half a second to 2 seconds, display in an hourglass or something rotating some kind of progress icon in animated form up to 2 seconds. Animate that so that you know that system hasn't died. But that should be also done with care. Sometimes front end and back end are so disconnected that the animation keeps going, but the system is crashed. So connect them somehow with more information between hourglass and this hourglass and the application itself. Display a message indicating the potential length of the wait for any action that will take longer than 2 seconds. So if it is going to take longer than 2 seconds, up to 10, display a message. This may take a while. And dialog, this may take a while, and hourglass again, up to 10 seconds. Log scroll, giving some database indications, giving file names, showing file names with the progress bar is good because then you will understand that something is happening, program is installing, database is copying, files are copying, records are being transferred, so that thing is happening with the feedback. But with the animated progress bar, after 10 seconds, it becomes a long task. It turns into batch. So after 10 seconds, if the task is going to take more than 10 seconds, people usually switch to another window in the environment. When people usually switch to another window, you need to think about task switching, mental task switching. So they should come back when the task is finished. In order to make them come back, flash the screen or make a sound, make a pop-up notification, use notification bar or notification mechanisms to get people back from the other tasks. In desktop environment, it could be a sound, but in other environments, like mobile environments, it could be other means, notifications, etc. The file sent has been completed, so you can create a notification message from the top so that people understands that the task is finished and they can switch back to your application over 10 seconds. Trap multiple clicks of the same button or object. Double click, nothing happens. Double click, nothing happens. Double click, nothing happens. Then 3 copies are executed. So when people are trying to click multiple times on the same object, they don't mean that they want to create multiple instances. They want to start it for 1 copy. Okay, so please understand that. Because the internet or desktop system is slow or the application is slow, people tend to press the same button repeatedly. And this causes things to be slower. Furthermore, in order to prevent this, some websites says, please click only once. So that is also that's also not good. Trying to solve software design, interface design problems with instructions given to users. It is not a good way of solving the problem, but it solves the problem. They say, once you click submit, do not press again. But if they keep pressing submit button, why are they doing it? Because you are not giving the feedback. So you need to take that issue technically, not by instructing the user not to do it. Any questions? One thing I forgot to say. Sometimes the system is slow. For example, the search. In order to eliminate the perception of slowness, sometimes developers put intermediate dialogues, which are separated as a thread from the backend. For example, you type a search. You type a search string and click search. But it will take too much time, like 6 seconds, 3, 4, 5, 6 seconds. So people don't like it. As a countermeasure, as soon as you press search, you start search, but you also pop up a dialog. Dialog says, search is started. You say, okay. So when the person is dealing with the dialog box, search finishes. So popping up extra dialog, like, please continue. Search is started. Action is being, your command is being implemented. So some wishful thinking messages saves you 1 or 2 seconds. So as user is dealing with those messages, they don't feel the latency. So latency is the perception. If you can reduce that latency by giving additional messages or entertaining user briefly, then they feel that the system is fast. One anecdotal behavior that explains this is if your work in the bank, in a real bank, is long, they offer you tea. They offer you tea, and as you drink tea, time passes a little better. So you believe that it didn't take long. So similarly, if you entertain the user with animations or additional dialogues or other things, you can capture 1 or 2 seconds from the latency perception. If that latency perception is eliminated, then people will still believe that the search or the operation is not taking too long. Now, going back to contrast and visual structures, readability principles come back here. High contrast, black text on white or pale yellow background is easy to read. Stay away from gray backgrounds. So contrast is the key. Provide good contrast. Use font sizes that are large enough to be readable on standard monitors. If they are very small, people will have difficulty. One of the most important problems that we have found in bank application several years ago, we were doing a study with a bank, with a private bank. The problem was the monitors in the branch was very small, old-fashioned small monitors, but developers were developing the applications with big monitors. Developers usually use maximized browsers. With the maximized browsers, they like everything with their big screens, 27-inch monitors, etc. But when we go back to the bank in Kurtköy, in Tuzla, whatever, the monitors were small, not like the monitors of the developers, and they were having difficulty in reading. So it was the thing that was slowing down in many tasks, nothing else. So using font sizes that are large enough to be readable on standard monitors, used by the actual user, is important. Similarly, not everybody uses big laptop screens or big phones. Favor particularly large characters for the actual data and smaller characters for the labels. Labels or instructions needs to be smaller than actual data or slightly less bold. One, I will have an example coming, but do not bold captions. For example, you have a field like name Mehmet, okay? Name should be less visible than the Mehmet. Name should not be bold. It should be less visible in terms of font size and font weight. Okay, so with the new technologies, with the new session technologies, we can track the user. We can track where user is, what user is doing, what was wrong, etc. So tracking user state is critical in new user interfaces, and it is good for the business as well. Well, try to understand whether it is the first time or whether the user is coming multiple times, where the user is going, where the user was, what was the previous session, so we can understand. This is called as clickstream analysis, and it's an active research area. We can do many things with the clickstream analysis. One of my PhD students is now working on clickstream analysis. So it's kind of important. We will have a good example here. This is a heater control that we have seen at the beginning. There's a cover. This cover says, if you are advanced user, open it and adjust. But if you are standard user, day-to-day user, only these are sufficient. So having an option cover gives you the ability to go into detail if you want. If you don't want, they are hidden. They don't give you trouble. They don't confuse you. So confusion is prevented by making a cover, but the cover is openable. So if you really want, you can open and continue. This is a direct example of accommodating different levels of user. In the human computer interaction, usually there is big data coming, but small data going. So writing is very small with respect to what you read. Unless writing a text document, unless writing a letter, okay, or email, data entry is not frequent. Data entry is not much. Mostly, you consume data. Without a keyboard, data entry is difficult. And also, speaking is slower than keyboard. So you may say that you can dictate by talking, but you cannot talk as fast as you can type. It's tiring to talk. Unless one is writing a text document, data entry is less frequent, as we say. Without keyboard, it's hard. Therefore, what we can do, the default is important. Default values must be utilized in order to reduce the amount of data we enter. Giving examples next to the fields. For example, phone number. Is it going to contain 0? Is it going to start with 0 or not? So giving example to explain how you enter your phone number is a good idea. Or date, or birth date, or address. Any kind of, or your height. Sometimes smart lists increase efficiency and selection rather than data entry. reduces errors. If the application is a mobile application, in the mobile application, data entry history clipboard is very useful tools to reduce data entry. Making a money transfer using a banking application. The IBAN number, the famous IBAN number, some banking applications allow clipboard to be pasted as a IBAN number. So if you copy the IBAN number from other application, your text box, your email, when you switch back to banking application, and if you are in the send money menu, they ask you, do you want to paste the information in the clipboard, or they allow you to use the camera, they allow you to use photo gallery, etc., to capture the necessary text from the available resources rather than make you type. Also, chunking is interesting. Chunking is interesting. IBAN number TR12 14 00000000174 264, something like this. So in this case, you have trouble because when you look at the IBAN number, you are confused to count how many zeros. Do I have 7 zeros or 8 zeros? As you keep counting the zeros, your eyes fail. You can't count successfully. So in order to fix the problem, TR12 14 TR12 14 00 00 00 0017 4264. So when you group them, you create visual aid for the user. So copying those numbers, entering those numbers becomes much easier in both from the source and to destination in both cases. This is what we say. Also, saying this on telephone becomes easier to your friend. Otherwise, it will be very difficult because you need to create a mechanism that will be unique for the case, for that telephone conversation, and it will slow you down both. So keep in mind that the mouse is slower than the keyboard also. So mouse is not always good. Actually, it is not good. It's a convenient way of interaction. It is one-to-one mapping, but for data entry tasks, it is slower. You need to leave the keyboard, hold the mouse, find the cursor is, start controlling, click, and come back to data entry. So from one field to another field, passing from one field to another field should not be done with the mouse. It should be done with the keyboard, with the tab key. So tab key, for example, must change the field. Continuously used systems should not rely on positioning devices. Keyboard must be preferred. In the old black screen corporate computers, in old IBM computers with black screens, mainframes. Some applications were being used much faster than today. For example, preparing an invoice. Preparing an invoice was much faster in those days because there was no mouse. Today, there is a mouse. They have to choose items from the menus by moving, and it becomes very tiring after some time. Wrist and arm fatigue occurs. With the keyboard, it wasn't the case. Unfortunately, that is the case, and what we can do is, if there is a repetitive entry of text in the interface, try to make a design so that mouse is not necessary during the data entry. So tab key, space key, shift keys, arrow keys can work through in multiple fields. And lastly, if data entered is coded, code table should be placed next to the entry device, not at the back. For example, A means something, B means another thing. Okay, if this A, B, C, D means something, that should be available to user. Any questions, Mustafa? No questions.
It's clear. Thank you.
Okay. So one thing is, we have to understand that users enter data and they believe that they are correct. All incorrect users also believe that they are correct. In the exam, all of you believe that your solution is correct. You don't solve a problem in the examination by thinking that it is incorrect. You believe that it is correct. Same thing is true for the interface. Everybody thinks that it is correct, but they make mistakes. So to reduce errors, already entered values should not be erased when returning back from the next string. Entered, next screen. No, you didn't like it. Go back. Same data should stay. Especially if it is mobile application. For mobile applications, data entry is difficult. So when you go back, you need to keep the screen data intact. That will require additional programming, but you need to do it. That is extremely important with the devices without keyboard message. And are you sure messages are required for this purpose? Because data entry is costly. They may give up. Başlarım böyle programına deyip kullanmaya da bilirler yani. Çünkü bir sürü giriyorsunuz. Adresinizi, nüfus kağıdınızı, TC numaranızı hepsini girdiniz. Next screen yaptı. Olmadı. Geri döndünüz. Hepsi gitmiş. Bunun olmaması lazım. So multiple ways of providing entry is, this is a classical example. Apartment entry. You can search names or press the number. In typical standard system, Ali, Hasan, Ümit, Süleyman, Shadiye, etc. So You want to go to Ümit. You look Ümit. Is it third floor? 1, 2, 3. Or where was Ümit? In 3. Do you want to go to third floor? It's here. Do you want to go to Ümit? It's here. So same interface, because there are hundreds of flats probably in this interface, is provided. You can either type the flat number or search for the names. They are available. Nobody is hiding it. They are available, but through the interface. I'm not saying it is good, but I'm only saying that these are related. Obviously, this is an old interface from 90s, and there are better things that can be done about it, but it's direct complement of a traditional doorbell and also the intercom. You can talk. So 1990s, that means traditional has an influence about how we do things, how we envision things in our minds. Therefore, when we are doing data entry, how do we enter data in many times, in many cases, in real life, with the paper? So many data entry screens, interfaces, are similar to forms. Form is a cultural thing. It is commonly used in United States. All tasks associated with the government, school, municipality, okay, they are, or the companies, they are related and connected with the forms. Everything has a form. When we come back to Turkey, we have petitions, dilekçe, right? We have foreign students, Dorian and do we say Joris or Horis? What was your name?
It's Joris.
Joris, okay, not
Yeah.
H, okay. So in Turkey, maybe you are amazed that instead of using forms, we have dilekçe, so petition forms, which is free format. So it is more likely to, it is more similar to artificial intelligence free text parsing rather than having forms. So because verbal communication is more prevalent in our culture than written communication. In written communication, societies moved to forms over the years. But since we still keep solving our problems with talking to each other, explaining what was the problem and so trying to solve it, we use dilekçe, free format letter petition, instead of using forms. So form culture is more common in Western societies, probably because written civilization dates back several hundred years further. Therefore, it's good. Therefore, when we are designing data entry screen, trying to imitate paper forms. However, as I said, our Turkish culture thing is more into dilekçe and free format writing of what you want. And today's artificial intelligence text parsers, okay, are trying to accept free format data entries for doing tasks such as, I know an application which processes letter directives in banks. In the letter directive, you say, I want to send money from this account to my friend's account, which is who is in United States and has a bank number, blah, 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 this. So the parser understands what you are saying, okay, and does what you want. So that is the new technique. And now I am confused whether I have to say dilekçe is ahead of forms or form is ahead of dilekçe. I don't know. It is debatable. It is difficult for reader, obviously. It is good for writer. For advanced users, form is good because you are doing the same thing over and over and over. So it becomes standardized. Moving between the fields of the forms, tab key should be used. If it is a tablet or mobile, then clicking the next field should switch the field. Each field may contain selection control, up and down, and that requires bigger screen space for selection. But form comes from the paper. So anything we do with the forms, the metaphors, comes from the paper interaction. If you want to create new thing, you have to find new way of interactions. For example, submit. What is submit? Giving the form after filling to the person is submit. That is what submit. Submit the form. So submit the form in the computer is direct translation from the paper society. But in the verbal interaction, you start saying that I want to send money to my friend who was in the United States, etc. And the other side may say, stop. You say, why? If you want to send money to your friend in the United States, go upstairs. So in direct one-to-one interaction, there might be other things going on. So form filling could be done dynamically. As you fill the form, bottom parts of the form can change depending on what you fill. That is implemented by dividing form into multiple screens. Depending on what you enter in the first screen, second part of the form can change. You can submit, you can create different type of second part of the form. So you can keep collecting the correct information. So you can make branches in the dynamic form in the computer, but not on the paper. On the paper, they do it some way, saying that if the following if the answer to the following question is no, please move to question 17. So you can have something like this on paper, but it is very difficult and rare. It is only seen in some government forms, advanced government forms. Otherwise, each task has a different form in reality. In computer world, you can play with it. You can omit unnecessary parts as you go filling the forms automatically. In the other side, there is dialogue. It goes like a question answer. What do you want to do? Send money. How much money you want to send? So asking one by one. So it is used in less frequently used systems. It is good for novice users. We call it wizard on the PC interfaces. So wizard is the way to ask, what do you want? This, that. So getting information one by one. Advanced users may dislike it after repeated use because it slows you down. It slows you down, but prevents errors. So if you are more likely to make error, then wizard interface is better. Dialogue-based interface is better. If the user is comfortable with the interaction, an advanced user, then form-based entry is better. Dialogue-based interaction, dialogue-based data entry has lower error rate, longer task completion time. Also, it is easy for small screens. Some dialogue. One problem. One problem with the data entry is you keep entering data, nothing happens, something incorrect happens. Why? Because you believe that the system is talking to you on the same concept. That concept, that mode, that is called as mode. It is like which floor you are in the government office. You want to change your ID card. You enter the government office and go to second floor, start talking. You keep talking. You explained that you lost your ID card and you want to change it. You are a foreign student, etc., etc. You spend 10 minutes explaining your case. Then they say, next floor. So all your explanations are lost because you are in the incorrect floor. But you believe that you are in the correct floor. Otherwise, you wouldn't say that. Therefore, in a similar example, many mistakes, especially with small screens, are due to mode problems. User believes that you are in different mode, acts, but the system is in other mode. System is in setting, system is in some other action mode, and it doesn't respond as you expect. In order to prevent that, mode information is given carefully in good interfaces so that you don't make mistakes. If you are in setup mode, you continue your commands as if you are in setup mode. The famous Airbus accident in France in 1992. The accident I was talking about the accident I was talking about at the beginning was due to mode error. The pilots thought the equipment was in different mode, used the equipment because it was small screen, but the mode was different than they thought, and they made an error. So icons and one-line text is good for giving mode information. You have to give the mode. You don't expect people to remember the mode. In the line screen, for example, mode is very difficult to convey because there is not much space. So how do you do it? You do it by blinking cursor, underlying cursor, or cross square. So some kind of animation in the, you understand? So some kind of animation in the cursors or in the corner of the screen can say something about the mode, like in setup mode, error mode, emergency mode, regular mode, power save mode, energy saving mode. So different modes have different command sets and different responses. So if the user does not understand which mode the system is in and believes that the system is in other mode, many commands will be wrong. So mode information must be conveyed, or you can put additional LED somewhere. So that LED blinks, lights, doesn't lights in different colors. There are different ways of giving the mode. Let's give a break for 10 minutes. We'll come back in 12 o'clock. Görüşürüz arkadaşlar.
Görüşürüz hocam.
Okay. So this part is from Donald Norman's book. The controlling dialogue. Controlling dialogue is dialogue of the application. It is not a dialog box or dialog window. The controlling dialog is the main interface, the home screen of the application. That is the main screen. Main screen is regarded as a dialogue between the person and the computer. So there is a dialogue going on. The main application screen is the controlling dialogue. It's the part of the interface that allow us to move through the application and complete task. It consists of menus and tabs, toolbars, and buttons. So whatever you do is provided in the controlling dialog. The way we design controlling dialog is coming from the user and task analysis. We analyze the task, then we lay out the controlling dialog, and then that makes designing the software interface and then tasks. And it should be done based on how user thinks the work should be done, not how the developer, how other people believes. Many developers believe that database view is important. Therefore, they put a component to show database fields in vertical columns, but they don't think about the uniqueness of a record. They don't think about what the user needs. In one example, that was designed for police cars, I tried it in an early version. You type license plate in the number in the police car computer, and there is a big database screen component, one line, and the first screen was chassis number, then engine number, then serial number of the document, then screen is gone. You have to click the arrow multiple times in the car, okay, to see that whether the car is stolen or not. So in order to understand whether the car is stolen or not, you need to scroll down here, but in order to see the chassis number and ID numbers, which are almost irrelevant for the police, they are visible. Because the designer of the controlling dialog never thinks that they ordered the display based on the order on the database. So database order is followed. And also, only one display, only one card is displayed in the component. It's a unique record. So unique records should not be displayed in rows. If it is one record, display it in full screen. This, full screen. It must be displayed in full screen because there is only one. If the search hits multiple records, then you can display a list view. But if the only one record is found, display the result in a consumable format, which is occupying bigger screen. Okay, in detailed view. So unfortunately, this was useless. I hope they changed it. In the controlling dialog, menus are one important part of the interface. Almost all interfaces today have certain ways of providing menus. It's a common piece of complex user interfaces. Unfortunately, more and more Python project doers of our students do not rely on menus. They don't develop menus. They forgot developing user interfaces. Yesterday, one of you guys, girls, were showing me the project. She was showing me the code. There was no interface usable. There was an interface, but not usable. So try to focus on the interface because it gives the ability to use the application. If you cannot use the application, it's nonsense. So even if it's a text menu, there should be a menu and options and controlling dialog. You should not rely on IDE for using the program. When you develop a menu, the actual use becomes recognition-based rather than recall-based. When you use it from the IDE, it becomes recall-based. When you develop a menu, it becomes recognition-based. And the menu tree should reflect the system behavior. So the menu you provided gives out general idea about what this application is doing. When you have smaller screens, like mobile phones, you need to have deeper menu levels. When you have bigger screens, you may have less deep menus, but more selections at the top levels. In some cases, you only have numerical input device, like keypad only, in embedded devices, etc. If you have only the keypad, numerical keypad, menu items may contain numbers. For example, 1, save, 2, cancel. So these numbers can be pushed, or with the arrow keys, you can navigate on the screen. Either navigate or press numbers. So availability of numerical keypad allows you to add additional accelerators in selections, and it is good. When planning the pull-down menus are one type of the menu. There are other types of menus. Pull-down menus. When planning the pull-down menus for the application, you must decide on horizontal menu titles and vertical choices. The arrangement of these entries must be based on the user's view of the logical structure of the application. So what are we doing? What are the main tasks? What are the subtasks? So main tasks and classes and subtasks must be carefully studied with the post-it, with the brainstorming and arrangement, task analysis. Then menu structure will be laid out. This is what we call first level menu. This is what we call second level menu. So here the menu levels are two. First level, second level. In the menu, use the word that everybody understands. And if there is a menu title and the menu element, reading together should not be uncomfortable. Meaning that channel delete can be read out loud without problem. For increasing the efficiency, we talked about this last time. Channel delete repetition doesn't sound nice. So this should be dropped. It is inefficient. Okay. So if there is single line display, previous level can be repeated. If it is single display, not pull down display, this can be repeated because it gives you the mode. But if it is regular display, pull down menu, then it shouldn't be repeated. This is single line display example. With multiple lines, you don't have it, but single line, yes, you have. This is a real life example. Insert new slide. So when you read them together, it sounds nice. Therefore, we have insert new slide, insert duplicate slide, insert slides from. So reading becomes smooth. Insert text box. That's why we have insert. So as people use the menus, they read out loud from inside, and that should sound nice and linguistically nice. The ordering of the menu item has been a good topic as an exam question. Menu items must be ordered based on the following structure. If there is a platform standard, comply with it. That means, for example, new or quit. They have certain spaces, certain locations for placement. So follow the convention. Edit menu, follow the convention. Other than that, frequent tasks should come to the top. Frequently done things should be on the top in the menu because you click, you go down. Going down takes time. Therefore, top location is more accessible. If there is a chronological order before and after, former tasks should come before later. For example, open is before close. Because if you can't open, you cannot close. Therefore, open menu must be on top of the close because it is before. If there is a chronological order, like 2023, 2024, or spring, summer, or first year, second year, third year. Okay, so if there is some kind of chronological relation, before after relation should be followed as top and bottom the menu. If none of them applies, like city names, use alphabetical order. Okay. This is one example. The one on the left was for tax payment in one banking menu. It is sorted based on numbers. Okay. And the one on the right is insert again. And there's a grouping that I'm going to talk. These bars. What are these bars for? They are grouping. So they group certain things, and those groups are usually less than 7 elements, 7, 8, 9 elements. Not much, because once you see here, you understand it as a group and then decide in between. If it is more than 7, 8, 9, it becomes too long, so you cannot visualize all of them at once in your mind, and you can't choose it, and it becomes like this arbitrary selection or ordered selection. Therefore, we have separators, separator lines. On TV menus, on side example, sometimes they open on side. Keep the title if possible, and current mode should stay on screen. And arrow keys and OK select became standard for the menu. A problem was up arrow and down arrow sometimes work in opposite directions. Sometimes up arrow goes down, sometimes goes up, depending on how you orient yourself. So try to make it consistent in your interface if it is TV or similar equipment. Usually up arrow should be associated with screen up movement, but channel 17 to channel 18 up arrow increases the channel number, but on the menu channel 17, channel 18 is at the bottom. So as you increase the number numerically, you are going down on the visual list. How do you solve it? The solution is, if you are displaying the list, up arrow shouldn't work. It should be down. If you are not displaying the list, maybe you can choose up arrow for increasing the number. If there is a visual element on screen, you should follow the visual element. For the horizontal menu, it gives the visual structure of the application. Just by looking at the horizontal menu, we should be able to understand what the information is about, what the application is about, and how we can use it, how to navigate. For the menu depth, this is two-level menu. And this is what we call cascading. The maximum number of levels must be 3 or less. If you go over 3, it becomes unusable. And between the separation lines, Norman says group 4 or 5 elements, but I would say 7, 8 is the maximum. 7, 8, 7, 8, 9 is acceptable. So these groups. Ordering. Start. This is alphabetical. In the menu. Because there are too many. When the menu is selected, you need to give visual feedback by blinking the menu, then disappear. That is very brief feedback, but gives you the understanding that menu didn't disappear, that element is selected. That element is selected information is critical. You can check your interfaces. Some of them provide this feedback, some of them don't. Those who don't are incorrect applications, incorrectly written applications. Similarly, when you have a button, when you click OK button, you expect the dialog will go away, right? Yes, it will go away. But before it goes away, this should go down, then you should go away the dialog. Otherwise, it feels like you are blowing the dialog, not confirming the dialog. So you click OK, OK goes down, then dialog closes. Okay. So the entries are frequency of use, frequently used items are at the top, sequence before-after relationship. If there is a standard order, follow that. If there is a chronological order, follow that. If nothing happens, alphabetical order must be used. The wording of the menu entries should be based on a common jargon, common dictionary, not necessarily the terminology that designer recognizes. Wording should be consistent through the application. If you are familiar with this jargon, if you are financial consultant, then this is okay. But if you are an ordinary citizen, this is no good. You are trying to pay your taxes for some reason, and this is what you get. I have explained this. If there is a horizontal vertical relation, when you read together, then it should have a meaning. It should have a meaning together linguistically. If the menu leads to another menu, submenu, use arrow. And if the menu element is not performing an act, but it will bring a dialogue for the second stage, then use 3 dots. If it is immediately doing something, you don't need it. But if there is a dialogue at the back coming, 3 dots. Similarly, 3 dots. Additional work is required. It is not immediately happening. Okay. So there is other additional work. It's not single action. Therefore, what I say is use 3 dots and check marks, selected, unselected. Some applications use it to toggle between the values. It is not very good way, but It has been used since early days. People still use it. So check marks are also used in the menus, and the interface supports it. Abbreviations in the menu entries should not be used unless we are sure that all users understand the meanings. This is what check mark is. It's not as good, but sometimes helpful. And the accelerators should be limited. Alternate keys can be provided. More and more of the times, alternate keys are not provided, and I can understand that, because without pointing device, some applications are impossible to use, and we accept that. If we accept that, then alternate keys are not required. So Alt F, underline F, so that Alt F provides the same selection. This is only good for Windows descendant applications. For Mac, we assume that there is a mouse, and also for the mobile. Providing feedback when the selection is made is important. Function, control, alt, option, win key, etc. should be provided, but you shouldn't overdo it. Tabs. Tabs are this. In the United States Office culture, these tabs are slight small paper tops for the folders, so that they will be visible on the drawer. These are original tabs in the folders. So when you see them from the side, it looks like this. Okay. So naturally grouping and chronological relation must be followed. Frequently used items must come to the front. Front where? Front is on the left. So frequently used items, chronologically early items must be in the front. Later ones should be less accessed ones. So the ordering is basically the same as the menu ordering. So label tabs on the tab control with meaningful descriptors. Order tabs using one of the methods for the menus. Please ordering. Toolbars are shortcuts for the menus. These are the toolbars. These are the toolbars, example. So they should be grouped as if we are grouping the menu elements. Putting everything one after another in single row is not good. So you need to have some groups, so that groups have associated meanings. It enhances their function together. They could be on the top or left. Okay. Then for the toolbars, consult the user concerning the functions that should be placed in the toolbar. Divide the functions in the toolbar into logical groups and make some separation between groups. Use icons and make sure that these icons are field tested with actual users. Use application-specific icons that the user would recognize. And use mouse over help if possible. Then you are good. And don't overdo it. Don't put everything on the toolbars because it becomes less understandable. There are some examples from the book. Famous mailbox, calendar, traffic light, call, time, link, launch, folder, file cabinet, trash, etc. Internet, search, attach, calculate, directory. I don't know if this is what that is. So there are some common understanding icons. At the end, Windows have command action buttons. It's like save, OK, cancel. These buttons referred as disposition buttons. They are often used to complete or submit with conversational window. They sometimes open dialog that have their own command action buttons. For example, properties. When you click on properties, additional dialog pops up, and in that case, you sometimes put 3 dots on the button so people understand when you click, it will continue. It will continue functioning with another dialog. Like browse here. You have 3 dots. It's coming. It is not immediately doing something. Another dialog will come. Okay. These are generic buttons. That the other upper part is the specific task button. The guidelines are similar. Unambiguous labels for identification, standard names and meanings for generic windows like close, clear, exit, help. Don't play with those words. Try to make it standard. Use appropriate feedback when the button is clicked. So when the button is clicked, the button should move. Use appropriate access keys depending on the platform. Disable buttons that do not apply. If the button is not applicable, do not allow to be clicked. Make it gray. And in order to design how controlling dialog works, there are certain models. One model is to use state diagram. State diagram is called as transition diagram. In user interface literature, transitions from one state to another are caused by events. In user interface, the software is always in one state. Changing from one state to another state is triggered by user events. User changes the state from A to B. So if user changes the state from A to B, we can model the interaction with a state diagram and give input as a state input and give output from the software as an output from the state transition. So transition diagrams can be used. For example, user clicks a mouse on the button on the interface, changes to another state, and that triggers the transition to a new state. So clicking a menu, for example, state change in the interface. So how it is important? Because we want to minimize state changes. We want to optimize things. So modeling these interactions with state diagrams help us to understand what we are doing wrong, what we are doing correct. In the interface, the menu, toolbar, communication buttons, they can all be modeled with transition diagrams by drawing. Drawing everything is difficult, so only part of the important points can be drawn so that we can think and reanalyze. So don't expect to draw all the state diagram of the whole application. starting the menu structure. When the user clicks on any of the horizontal menus, sub-menu appears. When the user clicks on any of the action buttons, secondary dialog appears. When the user clicks on the toolbar, secondary dialog might appear. So these transitions, modeling on these transitions become very big for complex applications. Therefore, we don't do it that way. We draw limited part of it, limited part of the problem. We try to focus on the problematic parts. To speed up the process, some people developed a method to write down what is happening with some language. This language is called as user action notation. In the user action notation, for example, arrow is clicking, tilde is moving. So move and click, down, up, down. So this is move and double click. Okay. These kind of notations are specific to different developer schools, different developer types. But generally, when you go to Google user action notation, they are similar. For example, system response is indicated with exclamation mark, mouse down, key up, some movement with the mouse, and then down, mouse down. So it tries to describe what is happening. Okay. This is from the book. Mouse down, mouse up, group, one action, multiple actions, highlighting object, message from the display, data, text entry, etc. So these are interface notations. I'm not going to ask problems or homeworks with this user action notation. I just let you know that there is a language like this, and if you are really interested, you can look up user action notation from the internet. For example, another example here found. User clicks on the mouse. You clicks on the file icon, and the interface responds. So interface changes the color, and the state becomes file selected. So that's clicking on the file, the desktop. Then you can, for example, drag and drop. Drag and drop can be modeled with this. We said meaningful feedback is important. After the transitions are modeled, designer must create visual and verbal feedback to support the changes or with the messages. It could be subtle side view messages, or it could be dialogues. It could be status as following, or it could be subtle happening, but if you look, you look. If you don't look, you don't look. But they are important. Alert. They are dialogues. Something is going to blow up. These icons must be carefully selected. Usually, red is alert, yellow is warning. So warning and alert must be carefully balanced. You should not use one instead of another. In what cases we use? There are two types of error messages because there are two types of errors. The first one is the slip. Second one is the mistake. Slip is an error that you know the answer, you know what to do, but you mistype. You misclick. You mistype. You know that you are wrong. In the mistake, you don't know that you are wrong. Error is made of misunderstanding. This one is interesting because you need to really provide help. This one, just show a small, simple dialogue and let people do it. Let people do it again, then it will be correct. Like entering the password second time. Entering the password second time. Why is it happening? Because you typed it incorrectly. You don't say that the person is not knowing the password. You know the password, but you type it incorrectly. So this is called a slip. Mistake means you don't know the answer. So in both cases, the error message should combine the error and help processing. The response should include brief message and telling what it is wrong and how to correct it. One of the issues is in real life too. You make a mistake. Nobody wants to make a mistake, but you make a mistake because you think that it is correct. So one way of telling that you are making a mistake is to repeating what you want to do. Because when you repeat what people wanted to do, people will listen, oh, I didn't want to do that. Therefore, you need to repeat what people want to achieve on screen. You wanted to search Joe Biden. No records found. If you repeat this, people will realize that, oh, it is Joe Biden I was looking. It wasn't Joe Biden. So they will understand that it was a slip. They will correct it. So repeating the goal and target on error screen is very good. Otherwise, confusion continues. Write the message, the error message in therefore in goal and action format. You go to a government office and want to pay something, some get documents. You explain 5 minutes. They say, no. You are not satisfied. How are you going to satisfy? When they explain, you want to do this and you came to here, that's why you are incorrect. You have to go to there, etc. So when they explain what you are trying to do along with the error, then you realize that what you want to achieve is wrong, because it might be due to communication problem. Sometimes when I go to hardware stores, I ask for certain different pieces, weird things, and they say, no, we don't have it. Then I ask a second question. What don't you have it? They say blah, 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 blah. Then I realize that he didn't understand what I was asking. So I try to rephrase it. And at the end, I may find what I want. So the miscommunication can only be corrected by repeating the goal and action in the error message. In person to person too. When you have trouble with your friend, try to communicate. Try to communicate what was wrong by repeating the wrong thing. Maybe he didn't mean the same thing as you think. So include meaningful title in the message box. Write messages in the jargon of the user. Base the wording on the user's mental model. Use examples in the message, if possible, such as enter the date like this. Present messages at the appropriate time, not at the end. Wait, enter, submit. Date is wrong. It was the first element in the field, so you should tell me that it is wrong when I am doing the part. So use the give the error message as early as possible. Use selection controls rather than entry controls. For example, date combo. When you use date combo, it will be very difficult to enter the date incorrectly because it is selected. Never erase what user has entered on screen. Instead, highlight the error and allow the user to connect it. Joe Biden. Joe Biden not found. So when you go back, keep Joe Biden. Keep Joe Biden so that they can go and correct rather than typing again. Because when they type again, they may write Joe Biden again. Second time because of typing. Biden. So the guidelines about data entry is it could be typed or it could be selected. The general guidelines are there will be a flow. The flow is generally Latin alphabet originated from top to bottom or from left to right. All the fields needs to be filled are processed from top to bottom, left to right by the person. They should be consistent. Minimize input actions by considering using selection field, list, checkboxes. So try to minimize data entry. Try to use visual cues and defaults so that remembering and guessing is minimized. Try to align things. Align captions and fields. These are captions. Align captions and fields for easier readability. Reduce vertical alignment lines. What is vertical alignment line? I don't say align everything. It is like this. These are alignment lines. So there will be multiple alignment lines. This is one alignment line. This is second alignment line, third, and fourth. Try to reduce it, not to one, but not much. Align captions and fields separately to the alignment line. Okay, then it will look nice. Then there will be a balance, visual balance issue. For example, if this part is empty, then it doesn't look nice. So you need to put some visual weight to here so that it will look balanced. Therefore, put something here in the dialog. Move from field to field using tab key. Set focus to the appropriate starting point in the activation of the window. This is one interesting example. The page comes, typewriting, start typing the entry. It doesn't go. Why? Because the focus is not set. Focus must be set. So as soon as you enter the data entry window, typing can be started without going to mouse. Therefore, consider using a color highlight for the current active field, like pink or yellow or whatever visible field, or blinking. When you are typing, you need to be able to tell you are typing in that field without confusion. So data entry windows are two types, form-based and conversational. We said that some of them are form, some of them are conversational. Conversational ones are good for ATMs, online registration forms, interactive games, fine. But for professional systems, form-based windows are better. If there is a paper form, try to make it look like the paper form. Yeah, we have said that. We have said that. Okay, this is important. Design a window so that the density of the print and control is between 20%, 30% of the screen. So here is your window. That's around 30%. So this kind of busy place must be used. Some white space should be provided around. Otherwise, it will be difficult to use. Apply and scrolling paging strategy so that page 1, page 2, page 3, page 5, and then submit. Also consider using tabs. And switching from one tab to another tab must be guided with the next button. Yeah. When doing conversational windows, more careful design is required because there is no paper document. It is like talking. List the data that needs to be collected, estimate discussions, design the captions, identify what kind of input element will be used, then design the window on paper, check it with the user if this is understandable, then implement it. Without checking it, evaluate the design with the user first, on paper. That's important. Captions are first name, this is the caption. Use captions to label all data entry fields in the language of the user. Do not use abbreviations unless it is known. Do not bold captions. Align captions left or right. I like it to the right, but be consistent. Follow captions with a column if the caption is positioned to the right. Okay. Use captions to show formatting, like date or like telephone number, if this is not embedded into field. With the new technologies, we can embed it in gray with the field. So with the new technologies, we can put the format in the field. The problem is when you start typing and forget what the format was, the example goes away. So, but we can live with that. Here, for example, format information is in the caption. These are aligned and not bold. No bold captions. Everything is important in order to get a good-looking interface and good-looking, professional-looking dialogue. Otherwise, it will look crappy. Allow flexibility and try to reduce keystrokes. Selections could be radio button or checkboxes. Radio buttons are exclusive or selections. Checkboxes are only or type of selections. So you can select multiple checkboxes at once, but you cannot select radio buttons. So if there is an exclusive selection, use radio buttons rather than checkboxes. Mixing of these creates confusion in the user. So try to use the correct selection method. Again, drop-down combo. You can type and you can select together. Again, visible combo. You can type and some of them are visible. Smart lists. I think I should stop here because this topic is different. Validation techniques for data entry. Let me stop the recording. And I think this is good for this week.